5 5.6 indirect proof and inequalities in two triangles. So the first part of this section is the indirect proof, where we are going to be proving something is true in a roundabout fashion. Okay, we're not going to go directly at what we're trying to prove. We're going to actually start by making a false assumption. Okay, so here are the steps to an indirect proof. We've got to identify what we're trying to prove. Then what we're trying to prove, we're going to assume is false. So instead of thinking prove that y doesn't equal 12, we're going to assume the opposite in this proof. We're going to say assume that y equals 12, and then we're going to continue on with the proof until we find a contradiction. So with this assumption, I'm going to also say assume y equals 12. We are given, I'm writing this in a kind of a paragraph proof, we're given that x equals 3. Therefore, so here's the logical conclusion, therefore x plus y is the same thing as 3 plus 12, which equals 15 by substitution. So by the substitution property, we made that. So x plus y equals 15, and there is a contradiction. This, however, cannot be. This cannot be. So y cannot equal 12. So we were trying to prove that y didn't equal 12, and we started with assuming it did, and we then tried to see what we could, we were going to keep working through a proof just like we've been doing until we get to something that doesn't make sense. So we got to x plus y equals 15, but that didn't fit in with one of our givens. It's a contradiction. So what we assumed must not be true. It's a pretty powerful proof. The next two proofs are some pretty long ones. You could pause this and read through it if you want, but what I'm going to do is look at GeoGebra again. So the hinge theorem, I set these up where this side length is always 5, this side's always 8. This side's always 5, this side's always 8. And they call it the hinge theorem because it's a lot like a hinge of a door. The 5 and the 8 are going to stay the same length, but the angle will change. And just like the last section, we're going to look at what's the relationship between this side and this side for a given angle measure. So if these sides are the same length, and we're going to compare the angle between the two sides. So think of this as like the door opening, and here's the door. As this angle gets bigger, that side gets bigger. Okay, we knew that from the last section in one of those inequality theorems. So if this is a 75-degree angle and this is a 45-degree angle, which side length is going to be bigger, this side or this side? And as long as these two sides are the same length, they're congruent to each other, and then the angle between them, whatever angle's between them, that side's going to be bigger. And then the converse is also true. You could, I could show you 4.7, 5.8, which angle is going to be bigger? The 5.8. So those are the hinge theorems. And we can use those to answer a couple quick questions. In triangle ABC and DEF, AC congruent to DF, BC congruent to EF. AB is 11, ED is 15. If the measure of angle F is 58, which of the following is a possible measure for C? I read through this and I'm like, that's a lot of information. I need a picture. So I'll draw a picture. Does my picture have to be perfect? Nope. So I draw a picture, and I'm going to draw the two triangles the same. They're not, but let's do it. Label them A, B, C, D, E, F. And we know AC congruent to DF and BC congruent to EF. Okay, so now it starts to make a little bit more sense. We know AB is 11, ED is 15. So what can we conclude about if this is a 58-degree angle? Is that going to be bigger or smaller than C? Since this is 15, it's got to be, F has got to be bigger than C. Okay, could C be 58? No, they would have to be the same length, right? And they're not. So it's not 58, it's got to be smaller than 58, it's got to be 45 degrees. In example 2, you and a friend are flying separate planes. You leave the airport and fly 200 miles due north. Okay, so I'm drawing a picture again. You go 200 miles due north. Then you change directions to fly west. So we're headed west, that's our heading, but we're going to go 60 degrees north. Okay, 60-degree north for 90 miles. Now, your friend leaves the airport and flies 200 miles south. Then she changes direction and flies east. She's heading east, but 15 degrees south. Okay, so it's a 15-degree angle headed south. So heading east, but 15 degrees south. Not quite straight east. Which plane is further from the airport? So you look at this. This is a 90-degree angle and a 60-degree angle. So that's a total of 150 degrees, where your friend was going 90 plus 15, was only going 105 degrees. These were both the same lengths, 290. So by that hinge theorem, your angle's bigger. This distance is going to be greater than that distance. So we're going to say, which plane went further? You did. There's your homework. I'll see you in class tomorrow.